Air conditioning system in car using thermoelectric effect. Shelar. Abstract. According to International Institute of Refrigeration, air conditioning and refrigeration consumes around 15% of the total worldwide electricity and also contributes to the emission of CFCs, HCFCs, CO2 etc. Due to the use of such refrigerants, it leads to much harmful effect to our environment, i.e. the global warming. For air conditioning, use of fuel also increases, and all these are affect on the car efficiency. To overcome the problem of emission and fulfill the mismatch between the demand and supply of energy consumption, the thermoelectric air conditioning can be used. This system is not going to be noisy, there will be no hazardous emission to the environment, so the system is totally eco-friendly. As the Peltier module is quite compact in size, the design can be easily acquired according to space and need. Keywords: Peltier module, thermoelectric air conditioner. 1. Introduction. A thermoelectric module is an electrical module, which produces a temperature difference with current flow. The emergence of the temperature difference is depending on the Peltier effect designated after Jean Peltier. The thermoelectric module is a heat pump and has similar function as a refrigerator. It gets along, however, without mechanically small construction units, pump, compressor, and without cooling fluids. The heat flow can be turned by reversal of the direction of current. Thermoelectric cooling provides an alternative solution to the common compressor and absorber cooler. Thermoelectric coolers are used especially if small cooling power is required up to 500 W. Our goal is to define the new HVAC system using thermoelectric couple, which shall overcome all the drawback of current HVAC system. If this system comes in present HVAC system, then revolution will occur in the automobile. With rising population and pollution at an alarming rate, this system has come to rescue, as these are environment friendly and compact. Conventional compressor-run cooling equipment have more limitations related to energy efficiency and chlorofluorocarbon, CFC, refrigerants use. Both these factors indirectly point to the impending scenario of global warming. As most of the electricity generation relies on the coal power plants, which add greenhouse gases to the atmosphere, is the more cause of global warming. Although researches are going on, best alternatives for the CFC refrigerants is still on the hunt. So instead of using conventional air conditioning systems, other products which can efficiently cool a person are to be planned. By using other efficient cooling device, we can save the electricity bills as well as control the greenhouse gases that are currently released into the surrounding atmosphere. Although thermoelectric property was discovered about 2 centuries ago, thermoelectric device have only been commercialized during current years. The applications of thermoelectric vary from small refrigerator. 2. Literature survey 2.1 Conditioning system in car using, in present scenario, HVAC system, commonly used in the air conditioners, is very efficient and reliable, but it has some demerits. It uses refrigerants like freon, ammonia, etc. Due to the use of such refrigerants, maximum output can be obtained, but it leads to much harmful effect to our environment, i.e. the global warming. That leads to the emergence of finding an alternative of the conventional HVAC system, i.e. thermoelectric cooling and heating system. The present paper deals with the study of thermoelectric air conditioner using TEC module. Thermoelectric cooling system have advantages over conventional cooling devices, such as compact size, light in weight, low cost, high reliability, no mechanical moving parts and no working fluids. 2.2 Study of thermoelectric air conditioning for automobiles. Air conditioning systems is used in many automobile applications. The conventional process using refrigerant can cause serious problems to the environment. In this study we developed the air conditioning system based on thermoelectric properties. In this air conditioning, there is no use of compressor and pump for the refrigeration. Thermoelectric module is an electrical module, which produces a temperature difference while current flow. The emergence of the temperature difference is based on Peltier effect. The thermoelectric module is a heat pump and has the same function as a refrigerator. The heat flow can be turned by reversal of the direction of the current. Our aim is to introduce the new HVAC system using thermoelectric module, which shall overcome all the disadvantages of existing HVAC system. 2.3 Thermoelectric air cooling for cars. I am trying to overcome these demerits by replacing the existing HVAC system by newly emerging thermoelectric couple or cooler which works on Peltier and Seebeck effect. Thermoelectric cooling can be considered as one of the major applications of thermoelectric modules, TEM, or thermoelectric coolers, TEC. The main objective of this project is to design a cooling system installed on a conventional blower of car AC. The idea of cooling is based on Peltier effect, as when a DC current flows through TE modules it generates a heat transfer and temperature difference across the ceramic substrates causing one side of the module to be cold and the other side to be hot. The purpose of the project is to make use of the cold side to cool the ambient air to a lower temperature, so that it can be used as a personal cooler. Testing and measurements are also performed using Omkar, Maruti Suzuki Zen. A simple temperature controller interface with the cooling system has also been incorporated. Based on an analysis of sizing and design of the TEC air cooling for car, it can be deduced that the cooling system is indeed feasible. Readings taken during testing also testify to the fact that the TE cooling for car can lower the ambient temperature by 7 degrees Celsius. 3.1 Thermoelectric generator. A thermoelectric generator, TEG, also called a Seebeck generator, is a solid-state device that converts heat flux, temperature differences, directly into electrical energy through a phenomenon called the Seebeck effect, a form of thermoelectric effect. Thermoelectric generators function like heat engines, but are less bulky and have no moving parts. However, TEGs are typically more expensive and less efficient. Thermoelectric generators could be used in power plants in order to convert waste heat into additional electrical power and in automobiles as automotive thermoelectric generators, ATGs, to increase fuel efficiency. Another application is radioisotope thermoelectric generators which are used in space probes, which has the same mechanism but use radioisotopes to generate the required heat difference. Seebeck effect. A thermoelectric circuit composed of materials of different Seebeck coefficient, p-doped and n-doped semiconductors, configured as a thermoelectric generator. If the load resistor at the bottom is replaced with a voltmeter, the circuit then functions as a temperature-sensing thermocouple. A thermoelectric circuit composed of materials of different Seebeck coefficient, p-doped and n-doped semiconductors, configured as a thermoelectric generator. If the load resistor at the bottom is replaced with a voltmeter, the circuit then functions as a temperature-sensing thermocouple. The Seebeck effect is the conversion of temperature differences directly into electricity and is named after the Baltic German physicist Thomas Johann Seebeck. Seebeck, in 1821, discovered that a compass needle would be deflected by a closed loop formed by two different metals joined in two places, with a temperature difference between the junctions. This was because the metals responded to the temperature difference in different ways, creating a current loop and a magnetic field. Seebeck did not recognize there was an electric current involved, so he called the phenomenon the thermomagnetic effect. Danish physicist Hans Christian Ørsted rectified the mistake and coined the term thermoelectricity. The Seebeck effect is a classic example of an electromotive force, EMF, and leads to measurable currents or voltages in the same way as any other EMF. Electromotive forces modify Ohm's law by generating currents even in the absence of voltage differences, or vice versa. The local current density is given by J equals S-V plus EMF. Where is the local voltage and is the local conductivity? In general, the Seebeck effect is described locally by the creation of an electromotive field. EMF equals S.T, where S is the Seebeck coefficient, also known as thermopower, a property of the local material, and T is the gradient in temperature T. The Seebeck coefficients generally vary as function of temperature, and depend strongly on the composition of the conductor. For ordinary materials at room temperature, the Seebeck coefficient may range in value from -100 V/K to +1000 V/K. See Seebeck coefficient article for more information. If the system reaches a steady state where J equals 0, then the voltage gradient is given simply by the EMF. V equals S.T. This simple relationship, which does not depend on conductivity, is used in the thermocouple to measure a temperature difference, an absolute temperature may be found by performing the voltage measurement at a known reference temperature. A metal of unknown composition can be classified by its thermoelectric effect if a metallic probe of known composition is kept at a constant temperature and held in contact with the unknown sample that is locally heated to the probe temperature. It is used commercially to identify metal alloys. Thermocouples in series form a thermopile. Thermoelectric generators are used for creating power from heat differentials.